NASA's Stereo spacecraft resolved a 40-year mystery about how coronal mass ejections, or CMEs, change shape during their long journey. With new data processing techniques, Stereo scientists have succeeded in continuously tracking space weather events from the Sun's ultra-hot corona to the Earth, 93 million miles away. A CME is a huge magnetized cloud of electrified gas, or plasma, that bursts out of the Sun's atmosphere. It can be as big as 1.5 trillion tons of gas and travel at 3 million miles per hour. If a powerful CME hits the Earth's protective magnetosphere, it makes brilliant aurora and can disrupt satellites, radio communications, and even our electrical power grids. Despite decades of observations with NASA's heliophysics fleet of spacecraft, the details of the connection between activity on the Sun and its effect on Earth has been poorly understood. This is because CMEs change while traveling from the Sun to Earth, and it's difficult to track their movement with only a head-on perspective. Now, with Stereo's 2 spacecraft sitting on either side of the Sun, we can monitor the sky at large angles from Earth and can see the full ocean of empty space between the Sun and Earth. But CMEs are some 10 billion times fainter than the full moon, and were still too dark to see, until scientists applied cutting-edge image processing techniques to separate the CMEs from the star field. By applying this new technology, scientists were able to measure the absolute brightness of detailed features in the first large Earth-directed CME seen by Stereo, which occurred in late 2008. By the time the data were collected, Stereo A was nearly 45 degrees ahead of Earth in its orbit, affording a very clear view of the CME's path from the Sun to Earth. For the first time ever, scientists can watch a CME from its formation on the Sun to its impact with Earth's magnetosphere, ending decades of speculation about how features in the Sun's corona cause the massive, complex shape of the CME as it expands to 10 million times its size. This new ability to see developing space weather during its entire transit from the Sun will enable scientists to better predict when and how a CME will impact Earth, and understand how CMEs change between the Sun and our home.